Hi everyone. In this lecture we will integrate Spring Cloud Sleuth and Zipkin to our application. As mentioned in the previous lecture, Sleuth will automatically add trace ID and span ID into the SLF4G MDC as headers and include these IDs in the logs. We can then aggregate the logs and trace a message or failure easily. And with the Zipkin edition, we can then see the trace of a message in Zipkin UI and even get the duration of each step between the service calls. Alright, let's start by adding dependencies as usual. We will add Spring Cloud Starter Sleuth and Spring Cloud Starter Zipkin dependencies to the main POM.xml file with the already defined Spring Cloud version. We also need to add Spring Kafka dependency to be able to use Zipkin with Kafka. Then we will add these three dependencies to all services. Note that some of the services already had Spring Kafka dependency as they were using it previously. So let's update the POM.xml of Analytics service, Query service, Web client, Gateway service, Kafka Stream service. Note that this service has Kafka admin dependency and transitively Spring Kafka dependency, so we don't need to add Spring Kafka again here. Then Kafka to Elastic service. And finally Twitter to Kafka service. So actually we need to add Spring Kafka dependency only to Query service and Web client. Other services already has it. As you see, we added these dependencies even to Twitter to Kafka and Kafka to Elastic services, although they are not used in service-to-service calls. But Zipkin has a nice view to show dependencies in its UI, and by adding Sleuth and Zipkin to those services, we will be able to see all our services in a single picture, and even be able to see the data flow between the components. Stay tuned for that. Now, normally Sleuth will add trace ID header with name xb3 trace ID and span ID header with name xb3 span ID into the SLF4G MDC. However, since we use a custom logback file and override the format, we simply need to add those header values to the logback command file so that all the services that uses that logback file will get those headers in the log outputs. We still have the previous correlation ID here, by the way. We will not need it with Sleuth. If you want, you can remove this, as well as you can remove the MDC handler module dependency from all services. Great, with these changes, Sleuth is already configured. Let's now add a Docker Compose file for Zipkin. So I will create a file Zipkin YAML and add two Docker service definitions. OpenZipkin/Zipkin and OpenZipkin/Zipkin MySQL. So we will store the trace and span information on MySQL using the Zipkin MySQL container. And in the Zipkin container environment variables, we set storage type as MySQL, and then set MySQL host as MySQL, and MySQL user and password as Zipkin. We then enabled debug logging, and finally set Kafka Bootstrap servers to use Kafka as the intermediate source of communication between Sleuth and Zipkin, so that they will be decoupled from each other. We open port NIT 411 for Zipkin and set the global network from environment file as usual, so that we will be able to access to Zipkin container from our services that are running inside Docker. Let's also update the environment file and add Zipkin version as 2.22.2 and also update the compose file variable and add Zipkin YAML to be able to start Zipkin container with a single Docker Compose up command with the other services. Then it is time to update services YAML file. We will set the new properties for the services that we want to use Sleuth and Zipkin. If you want to use communication over HTTP between Sleuth and Zipkin, we need to set Spring Zipkin base URL environment variable to http zipkin 9411. As the default base URL refers to localhost, but we run the Zipkin inside the container of our application network, so we need to reach to Zipkin using the Docker container hostname, which is Zipkin. Note that when we use Kafka as the communication point for Sleuth, we can actually omit this Zipkin URL definition from the configuration. If you have the Spring Kafka dependency for some reason in your service and still want to use HTTP communication, you can then use Zipkin sender type as web. And if you specify the correct Zipkin URL, you will be using HTTP communication between Sleuth and Zipkin. So for Twitter to Kafka service, let's try this as an example and use HTTP communication by setting Zipkin sender type as web and set the Zipkin base URL as Zipkin 9411. Then set Spring Sleuth sampler probability to 1. This value can be between 0 and 1, and 1 means that we want to send all the trace and span data to the Zipkin. Then for other services, I will not provide the base URL, but instead set the Zipkin sender type as Kafka, and also set Spring Kafka Bootstrap servers. Note that we set Kafka broker hostnames from our Docker Kafka cluster here. This way, Sleuth will send the trace and span data to the Kafka instead of using HTTP calls directly to Zipkin. Here a Kafka topic named Zipkin will be created automatically to use in this flow. Then Zipkin will consume the Zipkin topic and put the data on its own persistent store, which is MySQL here. We then set the sampler probability as 1 again to collect all trace and span data. Let's set these Zipkin sender type, Bootstrap servers, and sampler probability configuration values to services query service, web client, Kafka stream service, analytics service, gateway service, and Kafka to Elastic service. Note that here we have two options for Zipkin sender type to use messaging between Sleuth and Zipkin, Kafka or RabbitMQ. And here we choose to use Kafka by setting this property to Kafka and also by adding Spring Kafka dependency. Great, we can now run Maven install commands with the skip test option to create the Docker images again. And then run docker compose up command to run the whole application. Let's first observe what's happening under the hood. I will follow the Docker logs for web clients, query service, and for Zipkin. Let's make a query in web client when all containers are up and running. As you can see, we have the same trace ID in the logs of web client and query service, so that we can easily trace a message using this information. Then let's check the health of Zipkin with curl commands by calling the health endpoint on the localhost 9411. As you see, all status informations are up and MySQL and Kafka connectors works correctly. Also, I will use KafkaCat to list the topics. And as you can see, we have a new topic called Zipkin, which is automatically created. Let's run a consumer with KafkaCat to see what is inside this topic. As we see, here we have the trace information sent from Sleuth. And in the Zipkin Docker container console, we have the logs, like Kafka polling returned batch of 1 messages. And that also means that we were able to send the trace data to Kafka from Sleuth. Let's now open localhost 9411 in browser to check the Zipkin UI. Here we can search for traces sent from our services. Let's log into web client and query some data again, say using Kafka as the search word. Then return to Zipkin UI and see the latest traces. As you can see, we got the trace from our search. And not only we see the whole path of our search, but also we can see the durations of each step between the service calls. Like here we see the path of a message coming from our query from web client. It first goes to gateway, then check if rate limit is not reached by using the eval SHA command, which actually runs a script on Redis to check the rate limit using SHA-1 digest of a script to run the script with better performance. Then it goes to the query service, and then goes to the gateway service again to call the analytics service, and then finally it returns the result. So here we can easily see all the duration spent in each steps between the service calls. You can also download this trace information as JSON to keep it in JSON format. Great! Here we have another view from Zipkin to see the dependencies. If we open this view, it will show us the big picture of our application, including the microservices, Kafka, Redis, and even the data flow from downstream component to upstream component. It is really nice to see all our components and services in such a graph with the data flowing in multiple dimensions, isn't it? So congratulations everyone! With this lecture we have completed the course. You really did a great job. I hope you enjoyed it as much as I did. Hope to see you in the new courses.